Hello and welcome to the 8th video of our Chapter 2 unit on data analysis. In this video we will learn how to do conversions between metric prefixes using the prefixes in the table that you have available to you. The US is one of only 3 countries that doesn't use the metric system, and this is going to cause some of you to have a little difficulty at first. Hopefully we'll work through that pretty quickly. The reason we use metric system in science is because the SI units that we use in science are based on the metric system. It's universally accepted and understood, but more importantly, conversions between 2 units of different sizes involve only powers of 10. Now you see the table to the right with the powers of 10. We'll explain those in a moment. You'll never have to memorize this table. You always get this whenever you need it available to you. And as you can see, the prefix is indicated by a number that determines it, gives it size. So M for mega is 10 to the minus 6. By the way, the ones in yellow are the more common ones we're going to run into. K for kilo is 10 to the third. Centi is 10 to the minus 2, and so forth. Now, when you use these as conversion factors, I want you to remember we're going to have the unit 1 is going to go with the prefixed unit, and the exponent is going to go with the base unit. So the exponent you see here is going to go with the base unit itself. And I like you to remember that by saying power to the base. Power is the exponent. Power to the base, we're going to put the exponent next to that base unit whenever we see it in the conversion factor. The prefixes are never going to be used alone. They will always be with another symbol, and that's how you'll recognize them. The only confusing one sometimes is M, because M means milli, but M by itself also means meters, and so it might confuse you. Hopefully you won't be confused by seeing M by itself. You'll realize that that means meters. Some examples. We have 1 milli, let's go to that milli again. 1 milliliter is 1 times 10 to the minus 3 liters, so milli means 1 times 10 to the minus 3. Another example, kilo, 1 kilogram is 1 times 10 to the minus, 1 times 10 to the positive 3 grams. And finally, 1 nanosecond, nano is 10 to the minus 9, so 1 nanosecond is 1 times 10 to the minus 9 seconds. Alright, so we're going to do some conversions. One-step conversions are going to involve conversions between a prefix and the base unit. It can go either direction. And when this happens, only one step is going to be needed. We'll use the table to determine what conversion factor we need from the starting equality as we set up our dimensional analysis. So for example, we want to know current computer transistor gate oxides, these are devices used in computers and cell phones and good things like that, approach 32 nanometers in width. How many meters? There's our M by itself, and that's going to be our question mark. How many meters is this? So let's set up our equality. Question mark meters is equal to 32 nanometers, and we're going to set up our conversion factor. 1 nanometer is 1 times 10 to the minus 9 meters. Notice the power is next to the base. Power to the base. Start off our solution. Let's bring the number down. We're going to do the railroad tracks method here. 32 nanometers is where we're starting because we have nanometers in the numerator here. Nanometers in the conversion factor is going to go into the denominator. Bring the 1 times 10 to the minus 9 meters down. We cancel out the nanometers. Let's do our zigzag math. 32 times 1 times 10 to the minus 9 divided by 1. And that gives us our answer of 3.2 times 10 to the minus 8 meters. Alright, let's try a different way. Let's see how many microliters there are in 10 to the minus, in 4.56 times 10 to the minus 3 liters. So we're going to start with our base unit. Liters is L, capital L. And we're going to go to microliters. So let's set up our equality and our conversion factor. Our equality, how many microliters are there in 4.56 times 10 to the negative 3 liters? Micro from the conversion table is 1 times 10 to the minus 6 liters. Let's start our conversion, bring down our starting equality because we have liters in the numerator. The liters is going to go into the denominator. In the conversion factor, we bring our microliters down here. liters cancel out, do our math, and we get 4.56 times 10 to the third microliters. By the way, micro is sometimes difficult to draw. You start with a tail, come up, and draw a U. So it's a U with a tail on it to begin with. Start here, move up there, and then do a U, and you'd be good to go. By the way, make sure you show all of your work for full credit. If you don't show all the conversions, then you're going to lose points. I don't want you to just move the decimal point, and I don't want you to use King Henry. Those are tools that are no longer of use to us. Two-step conversions are going to be required if we go from one metric prefix to a second metric prefix. When we do this, we're always going to go through the base unit. We're going to start converting one prefix to the base unit, and we'll convert the base unit to that ending prefix. So let me show you how that works. The joule is the SI unit of energy. We'll use joules in Chapter 5, starting in Chapter 5, we'll learn how this works. We want to know how many kilojoules, kJ, kilojoules, are equivalent to 367 millijoules, mJ. Alright, so our starting equality, question mark goes with kJ, with the kilojoules. We want to know how many kilojoules are equal to 367 millijoules. Milli is 10 to the minus 3. Kilo is 10 to the third. So set up our conversion. We're going to do the conventional conversion method. 367 millijoules. The millijoules goes into the denominator in the conversion factor. So 1 millijoule in the denominator cancels out. 1 times 10 to the negative 3 joules in the numerator. Now if we stopped here, we would have units of joules, but we want kilojoules. So let's bring joules down into the denominator to cancel out the conversion factor. Kilojoules goes in the numerator. The joules cancels out. And we can do our math. Remember that zigzag. And we get our answer of 3.67 times 10 to the minus 4 kilojoules. Let's do one more before I let you go on your own. We have a Blu-ray player. These are Blu-ray discs. It uses a blue laser beam with light of 405 nanometers. We'll see this in Chapter 5 as well. We want to know how many centimeters is this equal to. So we're going to convert from nanometers to centimeters. Centimeters is our unknown. 1 nanometer is 1 times 10 to the minus 9 meters. Centimeter is, centi is 10 to the minus 2. Let's bring down, we'll do the railroad tracks method this time, our 405 nanometers. The nanometers from the conversion factor goes into the denominator. Cancel out our nanometers. 1 times 10 to the minus 9 meters is up top, leaving us with units of meters, which are going to cancel out. We're going to bring that meters into the denominator to cancel out the meters. Put centimeters in the numerator. Centimeters is the answer, is the unit we're looking for. So let's do our math. Forget the zigzag. And that equals 4.05 times 10 to the minus 5 centimeters. All right, I think you're ready to go. Let's try this on your own now. We have a student who has a mass of 58.97 kilograms. What is their mass in grams? I'm going to pause the video. When you're ready, hit the play button to get the video started again when you have the answer. All right, so we've got the answer. Let's see what you did. We're going to start in kilograms. Oop, wrong pen. Kilograms. We want to know our answer in grams. Because we are going to the base unit, this is going to be a one-step problem. We only need one conversion factor. Here's the setup of our dimensional analysis. Kilo is 10 to the third. 58.97 kilograms. Bring this down. Kilograms goes into the denominator. 1 times 10 to the third grams goes into the numerator. Kilograms cancel. Now we have units of grams, which is what we want. Let's do our math. And the answer should be 5.897 times 10 to the 4th grams. All right, our next problem. Convert 6.99 times 10 to the 8th micrograms to centigrams. Push the play button when you're done. All right, so we're back. Let's see how we did. Micro and centi are our 2 units. So since we have 2 prefixes, this is going to be a 2-step conversion. Here's our setup. Micro means 10 to the minus 6. Centi means 10 to the minus 2. Let's do the railroad tracks method. Bring down our starting equality. Micrograms goes into the numerator to cancel out. So 1 times 10 to the 6 grams in the numerator. So micrograms goes in the denominator. Maybe I said that wrong. Micro goes in the denominator. Grams goes in the numerator. Cancel out the micrograms. Now we have grams. Take our grams from this conversion factor, put that into the denominator. Centigrams goes in the numerator. We cancel out the grams. We're left with centigrams, which is the answer, the unit that we're looking for. Do our math. And we get our answer of 6.99 times 10 to the 4th centigrams. All right, so to help some of you along, sometimes you don't have to do that method, and we have a new method that I learned last year that helps people who have a little difficulty in putting together the conversion factors as I've shown you. This method, the prefixes are treated not as part of the unit, but they're going to be actually part of the number itself. We're going to replace the prefix by its exponent in the number, the value. Then we're going to take the desired prefix, the new prefix that we want, and we're going to multiply our number by the prefix and its inverse, which is effectively multiplying by 1. So we're not changing the value at all. And then we're going to regroup the exponents, and that will show us the value of our number in its new prefix. Let's see how that works. So our first problem, we're going to convert 768 milligrams, milli is 10 to the minus 3, to micrograms, 10 to the minus 6. I want to do a prefix to prefix conversion here because it's going to show you the full method, and then we'll show you it gets simpler when we do a prefix to base or base to prefix. All right, the setup is a lot easier than before. What we're going to do is just rewrite the number, but as we rewrite the number, we're going to take that milli, that m, which means 10 to the minus 3, and we're going to put that in place of the m. So 768 times 10 to the minus 3 grams. So far, we haven't done much. Now let's multiply by 1 by taking the new unit, the desired unit, in this case micro. Micro is 10 to the minus 6. We're going to multiply by 10 to the minus 6. Put the desired unit next to the base unit and multiply by its reciprocal. 10 to the 6 times 10 to the minus 6 is 1, so we haven't changed the number at all. Here's the trick, and here's how this method really works. We're now going to take and regroup our numbers. Remember, multiplication doesn't matter how you group it, so you can regroup it any way you want. And let's group together the numbers that are not the exponent we're looking for. We're going to leave the exponent that we're looking for alone by itself. Now let's do some quick math. Take that 10 to the minus 3 and 10 to the 6th, multiply them together. That gets us 10 to the 3rd. We still have our unit that indicates micro by itself. Let's convert that unit 10 to the minus 6 micro to its letter, its prefix, mu is micro. And that leaves us with a value of 768 times 10 to the 3rd micrograms. Now you recognize that this is not considered scientific notation. However, the value is correct, and I will let you use this as your final answer as long as we're not in a unit or not trying to have you write the number in actual valid scientific notation. However, if you did want to convert it to scientific notation, we're going to take that decimal point, we're going to move it 2 places to the left, and so we put it into after the 7. Since we've decreased the coefficient, we're going to increase that decimal point by 2, that exponent by 2, and we get 7.68 times 10 to the 5th microgram. But remember, you don't have to do that, only if you want to. Alright, converting from prefix to base is a little easier because we can skip one of the steps. So we're going to take 800.74 times 10 to the 2nd megahertz. Mega is 10 to the 6th. And we're going to convert that to hertz, which is the base. By the way, hertz is a unit of frequency. We'll see this in Chapter 5 as well. So we're going to change the prefix to the factor. Mega is 10 to the 6th, so we're going to put that 10 to the 6th in place of our m. And it becomes 10 to the 6th. All right, we have no prefix needed, or no exponent, no factor needed for our base unit, so we can skip step 2. We're going to multiply the exponents now. Okay, so there's 2 exponents there. Let's multiply them together. You won't always have an exponent here. If you don't, then you're fine. You don't have to do anything else. Now we have 8.74 times 10 to the 8th, and there's our base unit hertz, and we are done. That was pretty simple, right? If this is not valid scientific notation, you can rewrite if you want to, or if it's required for that particular problem. Going from the base to the prefix is also a little bit simpler. So we're going to go from our base unit of liters to milliliters. Milli is 10 to the minus 3. So let's write the number. You're going to start from the base unit, so there's no prefix to replace. So we're going to start right with step number 2. We're going to take that 10 to the minus 3. We're going to multiply by the 10 to the minus 3, put that next to the base unit, and multiply by its reciprocal, 10 to the 3rd. Regroup, or in this case you're really ungrouping. Oh no, you are regrouping factors, sorry. 10 to the negative 2 times 10 to the 3rd times 10 to the minus 3. There's our desired prefix by itself with the base unit. Do our multiplication, 10 to the 1st. There's our base unit. Now replace the base unit. Replace the prefix with its, replace the factor with its prefix of milli. We have 3.28 times 10 to the 1st milliliters. This is your answer. If you want to stop here, you can, or if you notice, if you recognize, you can convert this to decimal notation. 32.8 milliliters. All right, your turn. As before, I'm going to stop the video after each problem, and you'll work out the problem on your own, and then you will come back and see how you did. Our first problem, convert 41.3 kilometers to nanometers. Alright, so you've restarted the video. Let's see how you did. We're going from kilometers, kilo is 10 to the 3rd, to nanometers, which is 10 to the minus 9. Start off with our 10 to the 3rd, replace the k with 10 to the 3rd. Now let's bring that prefix in. Prefix goes here, the new prefix for nano multiplied by its inverse. Let's regroup 10 to the 3rd and 10 to the 9th. Get regrouped, leaving us with our nano exponent right there. Do the math, 10 to the 12th. Now we're going to take that nano prefix, we're going to replace it with the prefix. We get 41.3 times 10 to the 12th nanometers. Again, not valid scientific notation. If you want to rewrite it, it's 44.13 times 10 to the 13th nanometers. Our next problem, convert 548.2 nanoseconds to seconds. Alright, so you've restarted the video. Let's see how we did. Nano is 10 to the minus 9, as we saw above. We're going to the base unit. So let's start off. Let's replace nano with 10 to the minus 9 right there. And guess what? Since you don't have anything to multiply by, this could be your final answer. But if you want to make it into valid scientific notation, we would have 5.482 times 10 to the minus 7. And seconds is the base unit. One more example. Let's convert 254 joules to kilojoules. And we're back. So let's see. We're going to convert from the base. Kilo is 10 to the 3rd, so we'll convert to 10 to the 3rd. We're going to skip step 1 because there's no factor here to replace. We're going to just go right to step 2, where we put the prefix next to the, or put the factor next to the base unit, multiplied by its reciprocal. Regroup, or in this case we're just ungrouping, get the 10 to the 3rd together with the 254, 10 to the minus 3 together with 254. 10 to the 3rd is together with the joules. Replace the 10 to the 3rd with its k. So now we have kilojoules, and we have a valid number here, 254 times 10 to the 3rd minus 3 kilojoules. You could convert that to valid scientific notation, 2.54 times 10 to the minus 1st joules, or just convert that to decimal notation, 0.254 joules is your final answer. Alright, so we are done with this video. I will see you in class tomorrow where we will work more on working through these conversion problems.